Oh, okay. So we look over to Algebra 1, guys. On Thursday, the 9th of January, SWBA students will be able to solve systems by substitution. Section 5.2. So before last section, 5.1, we talked about solving systems, and we did it by graphing them. We just did that in our warm-up, just did that in the homework we just checked as well. Okay. Now we're going to be talking about solving systems in another method. We're going to talk about solving them through substitution. Now we've substituted before as well, right? We substituted to check answers a lot of times, or we substituted when we evaluated functions. We said, hey, what's the value of f of x if x is 2, or something like that, okay? We've done things like that before. So same idea, okay? So in sports, a coach will substitute one player with another player who plays the same position, right? You don't want to, like, let's say we're playing football, okay? You don't want to substitute, you don't want to take out a running back and then throw in an offensive lineman in a spot, okay? Unless you're trying to do a trick play. That's probably not going to work that well, okay? Or let's say volleyball, you don't want to have a defensive specialist go front row more often than not unless they play all the way around anyway, okay? So same kind of thing. Soccer, I wouldn't want to throw in one of my strikers as a goalkeeper in just the middle of a game without them being prepared. That's not smart, okay? So you want to substitute them with the same position, right? You want to line those things up, okay? Basketball, you're not going to take the post and put them out on the wing, okay? That's you can, but it's probably not the best move, right? Yeah, like I don't want Joel Embiid shooting threes all game, okay? That's bad news bears, okay? And I don't want Steph Curry getting low and getting dirty in the lane. I don't want that. Like that's not a good idea, okay? So example 1, okay? So what's going to happen here? We're going to do the same thing with variables in an equation. So we're going to take one variable and substitute it in for that same variable, okay? We want to make sure we're lining up the positions just like a coach would, okay? So, in example 1, if we have these two equations, we have a system of two equations. We have y is equal to 2x and y is equal to x plus 5. Last section, what we would have done is we would graph both these equations. Okay, we would graph them, find where they intersect. That's good. This section, what we're going to be doing is we're going to say, hey, y is equal to 2x, y is also equal to x plus 5. So just like before, if we had known, let's say maybe y was equal to 5, could we plug in 5 and say 5 is equal to 2x? Could we do that? Yeah. Okay, because that's what y is equal to. So we're going to do that same idea, but instead of saying y is 5, we're now saying y is equal to 2x. So we're going to take this 2x and we're going to put it in for y. So the same idea, even though it's not just a number, it's now 2x instead of 5, or just 2, or any number. Okay? So we're now going to take this 2x, plug it in, or substitute it in for the y in the other equation. So what's going to happen here is I'm going to write this equation, but instead of y, what am I putting there? 2x. So I'm going to put 2x is equal to x plus 5.
May I sharpen my pencil?
Yes, you may. I would choose that one on my desk, though.
I was going to.
Dope.
Let's
Dang. Liddy. Okay. Now we're able to do this because we said, hey, that's what y is equal to. We said y is equal to, it's the same thing as 2x. So because this is the same thing as y, it plays the same position as y, we're able to put it in place of y in the other equation, okay? So now we have this new equation. We have this new equation, 2x is equal to x plus 5. We have this new equation, 2x is equal to x plus 5, okay? Jason, I'm going to ask you to hold your question because I think I know what it is, but it's a little bit later. I'm going to get to it. Or is it a question on how we got this? Okay. Is it like a hypothetical? Could we do something else? Okay, yeah. Okay. Thank you for being patient with that. I appreciate it. So 2x is equal to x plus 5. Can we solve this equation? Yeah, that's one we've been doing since the first month of school. Okay, so how do we solve this equation for x? 2x. Okay, you could subtract 2x, but you already have x's over here, so it's probably better to subtract this x, right?
Yep.
And subtract it from both sides. What's 2x minus x?
1x.
1x. Here's
X if you would.
And then what's x minus itself?
Nothing.
Nothing.
It
0.
cancels out.
And so we have 5. It zeroes out. So x is equal to 5. So we found out what x equals. But here's the thing. We want not only the x, but what other variable do we need to find? Y, okay? So we found x. We made a new equation by substituting. And now we gotta plug in the 5. And the question becomes, where do we plug in the 5? And I would say, it doesn't matter which equation, okay? It doesn't matter which equation we pick here. We can pick either of these two equations, but what variable we're gonna plug it in for either time? X, okay? So do you guys have a preference on whether we plug it in into this equation or plug it into
The
this
top
equation?
one,
The top one? Okay.
that's big duh.
So you can say y is equal to 2 times 5 instead of 2 times x. And so what is 2 times 5?
10.
10. So
Plus
y is
y.
equal to 10. Now, how are we writing our answers for the homework today?
I don't know.
You wrote them as an ordered pair, okay? So we're going to do the same thing here. So how would I write this as an ordered pair?
You have to do the other.
5 comma 10, we do x comma y. And that would be our answer.
That's a big yikes.
And in the same way, we could go through and we could check it by plugging this back into both equations.
But we don't.
Okay. Now let's talk about a couple hypotheticals from this. Okay. Because I know there's a couple hypotheticals we're thinking of. Okay. As I had said earlier, hey, once we had x was equal to 5, I said it didn't matter which equation we plug it in. Let's test that. Okay. Let's plug it in right here. Y is equal to 5 plus 5. What's 5 plus 5, guys?
10.
10. So do we still get the same y?
Yeah.
Yeah, so it didn't matter which one of the two we plugged x back into. Okay? We had to plug it into one of the original ones, because these two still have y. The one we made by substituting does not have y, so that's not one we want to plug it into. We want to plug it into one of the original equations. We don't care which. Just pick one, and normally we like to pick one that's easier for us, okay? These are both about the same, but sometimes there'll be one that's like, oh, that's easier. Okay? Now, Chase, I'm guessing your hypothetical was, Mr. Kossel, could we have taken this and plugged it in up here? Okay, that's a great question, okay? So let's say we had restarted this problem over here, okay? You don't have to write this down. This is the hypothetical. Y equals 2x, y equals x plus 5. Did I write just the same two equations? Yeah, I did, okay? So let's say, well, what if we had said, well, y is equal to x plus 5 here. Y is by itself. We know it's the same thing as x plus 5. So instead of taking 2x and plugging it into y, can I take this x plus 5 from this one and plug it into the y up here? And I'm going to say, heck yeah, you can. It doesn't matter which way you go. So then I can have x plus 5 in place of the y is equal to 2x. And it still works because we're saying y is equal to, it's the same thing as that. And hey, x plus 5 equals 2x. 2x is equal to x plus 5. What's the only thing that changed between these two equations in the dark blue and light blue? You just flipped it around. And we said mathematically, that's the same thing if you flip it around, right? Okay, it doesn't matter whether you have 2 plus 3 or 3 plus 2. Okay, you can flip those things around, and we're okay with that. So we're still going to get the same answer. You still subtract x, 5 is equal to x, just like we get x equal to 5. Plug it back in, we'd still get y is 10. Okay, so we'd still get the same answer. Okay, so it really doesn't matter which one you substitute in for the other. Okay. The important part is that we knew y is exactly 2x. Just like we knew, like if a hypothetical before, we knew y was 4 or y was 2. You plug it in, same thing. Y is exactly 2x because y is by itself and it equals this. Well, y is exactly x plus 5. So we just plug it in for another y somewhere else. We substitute it in. Yes?
Isn't it just one x and then it's like plus 5 with it? But you already know the 5's the x because you just look at every other problem, so why do you have to write it out? Because like if you do y equals x minus 4 is a negative 4
So you're talking about the y-intercept?
Yeah.
And that just happened to be the case this time that we had a 5 there, but it won't always work out that way. Okay, that's a great question. Yeah, we'll still have to go through and do this math here. Okay, so James was talking about, hey, Mr. Kossel, the setup here, I see this plus 5. Could we have already known it was 5 down here? Okay, that kind of thing. No, we couldn't have. It just happened to be that way this time. There's not really a pattern there. We're going to go to the second example, okay? We're going to talk about this one, okay? So we have these two equations, y equals 2x plus 1 and y equals 3x minus 4. Now, what can we do here? Okay, well, do we know what y is equal to? Yeah, it's 2x plus 1, is it a specific number? Is it like 3? No. Not added together, but we can take this and we can substitute it into the other y. Because we know what y is equal to, so we can take this and substitute it in the other y. Could we also go the other way around? Could we take this and substitute it into this y? Yeah, we could, because we know what y is equal to. So it really doesn't matter. And so we can end up getting 2x plus 1, which is now this y over here, the second equation, is equal to 3x minus 4. So what we did is we rewrote the second equation, but instead of y, we substituted in what y was equal to in the first equation. We said, hey, these are going to be the same thing. These are playing the same position. Okay? These are playing the same position. Okay? They're both playing quarterback. They're both playing post. They're both playing outside hitter. Okay?
Who's the outside hitter?
Volleyball. They're the ones that usually spike the ball. So, what?
That's
I
weird.
feel like it's pretty normal. But
It's weird, bro.
they're both playing point guard, okay, that kind of thing. They're both gonna take the ball up. So
Basketball game tomorrow. You see that?
Play point
Oh,
guard, got
yeah,
you
yeah.
game.
I just TikTok and by the way, I did my basketball game.
okay, so 2x plus 1 is equal to 3x minus 4. What can we do with this equation now?
Maybe you lied.
Solve it for x. How do we get x by itself?
Subtract 2x.
Our good goal would be to get all the x's on one side. 1 is equal to x minus 4.
Oh, I got that.
Now what do we want to do?
I want to
4.
add 4 because, like, yeah, you don't want to, like,
Okay.
See, I already.
So 5 is equal to what? X. So in this case, x happens to be 5 again. It won't always be 5, but happens to be. So now, once we have x, what else do we need to go back and do?
Then you need to plug in the other one.
Plug it in for y. Does it matter which of these two we plug it into? No. Do you guys have a preference? Dalton, do you have a preference between the two? Why?
Aggressive.
It's 2. It's 2 instead of. So it's smaller numbers, right? Do you like smaller numbers?
What do you
Yeah,
mean
let's
it's
talk about
cool?
bank accounts. Yeah, we're talking about that paper, okay? We want smaller numbers, okay? So let's go up here, and let's plug in this x equals 5 into one of these original two equations. Dalton says, hey, Mr. Kossel, I prefer the first one. There's smaller numbers, okay? You can do either, you'll get the right answer, as long as you do your math correct. But Dalton said, hey, the top one has smaller numbers. Why not choose it? Like, that's a good idea.
Add lit numbers.
Unless you're like, I really want to subtract 4. You just get really excited about subtracting 4, then go ahead and do that one too, okay, if you really want to. So what's 2 times 5? 10. And what is 10 plus 1? 11.
Then that equals y, and then you can blah, 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 blah.
Then how do we write our answer?
Then you can put 5 power 11.
As an ordered pair, x, y, bada bing, bada boom.
Well, that's oddly weird because that other one's like one.
Ooh, yeah, this kind of happens.
Everything
Okay.
is weird.
Low key
So-
whack, dog.
You're low key whack. Actually, you're high key whack.
You're high key whack.
Probably. Okay, so
Your high key mixed with low key.
once again, because y, the only reason we were able to do this, guys, was because a variable is already by itself. We knew y was equal to this, and so we're able to plug it in.
No.
Alright. Let's look at example 3 here. I want to show you guys something. 2x plus y equals 5, and y equals x minus 4. In the first equation, do we know what y is equal to exactly?
Yeah.
Do we, in the first one?
Oh, no.
No, y is not by itself. Here, we knew y was equal to 2x. It was equal to x plus 5. We knew it was 2x plus 1. We knew it was 3x minus 4. We don't know what y is, because it's not by itself. And we don't know what x is either, because it's not by itself. But in the second equation, do we? Yeah, what is y? X minus 4. So we can take this x minus 4, and what are we going to do with it?
Plug it
Plug it into where?
Top.
The top equation for x?
No.
No, for y. Because we said y is equal to this. So we're saying this can take the place of y. That's what substitution is. We say, hey, it can take the place of that. Okay? So what we're going to do is we're going to rewrite this top equation, and everything stays the same, except for now y is x minus 4. So we have 2x plus, and then we put all of y in here. X minus 4. And then I put equals 5. So it's the first equation,
Done.
and everything stays the same, except for now y is that x minus 4? Because we said, hey, in the bottom equation, y is the same thing as x minus 4 because it's equal to it. So we're able to substitute it in. Just like if you had y was equal to 4, y was equal to 2, y was equal to 0, you can plug it in. Substitute it in. Okay? Any questions on how we got that equation?
No.
Once we have that equation, I feel pretty confident in our ability to solve this, okay? You guys have shown me over the course of the first semester, you guys know how to solve this equation, okay? So I'm going to ask you to go ahead and solve that equation and find out what x equals.
Can you come check my?
Okay? Yes. Sure.
I did it.
Right. You can solve this one for y. Yeah, you can do that. You can solve for y if you want. That's perfectly fine too. So we're just finding what x equals right now. We're solving this equation for x.
So, take it away.
Alright, too small to even hit.
You know what? What?
Dylan.
Oh, hello.
Oh, yeah, you took it already. So what do you want to get away from it? Bet.
That's what people. What? You get to the bit of it.
Okay.
No.
Make this back to x. Can we combine x?
Oh, yes.
Yes, I see. Let's do x. Yes, let's start off with
Gotta
x
break our
minus 4. Have they equal 5. Let's go with 5. Yeah.
There's two ways.
Like 190 right now.
190.
How tall are you? It's like 5'9", 5'10". So if I'm like soaking wet, 5'10". Get it? They say you weigh more soaking wet. Someone's like, oh, I'm like 185, 190 soaking wet, 5'9", 5'10" soaking wet. So if you're soaking wet, like your head here, and so people say like, oh,
It's
like,
because you're big. You're probably 5'10".
Yeah. What?
You're probably 5'10".
that's what I have. My
Well,
list.
you also,
Yeah,
I'm like
shoes.
5'9". About it.
Like 5'9" and a half, I'm
Right.
only like 5 cents.
Right. Okay, let's go down here again. Okay. To solve this, what's going to be our first step?
You're going to distribute 1.
Okay, you could distribute 1 in the parentheses, okay, and have 2x plus x minus 4. Don't have to. We can just drop the parentheses if we wanted, but if you want to, that's fine. 2x plus x is 3x. And then 3x minus 4 is equal to 5. How do we handle this now? Add 4. Let's get that 4 away. 3x is equal to 9. Divide those sides by 3. X is equal to 3. Are we done there? We're done with what I asked, but are we fully done with the problem?
No.
No, what do we have to do now?
By the way.
Find the y. Does it matter where we plug it into?
No.
No, do you guys have a preference?
Bottom one,
Why did you say the bottom one, Dalton?
because it's already in intercept form.
It's already in intercept form. It's already solved for y. Y is already by itself, okay? You can do either equation, but if one of the equations already has the variable by itself, I would choose that one. Personally, you could do either. We can plug in 3 to x here and we get the right answer, or you can plug in 3 to x here and you get the right answer. Let's plug it in the bottom one. Y is equal to what?
Y is equal to 3.
Minus 4.
3 minus 4. So 3 is taking the place of x.
Negative 1 equals
Okay.
y.
And so then we have y is equal to negative 1. How do we write our answer?
Recombinant negative 1.
Recombinant ordered pair x comma y.
You know, this today's actually kind of easy. I'm not gonna lie.
Easy peasy.
Lemon squeezy. Unless there's fractions in a little bit.
Well,
You can do with that.
Then I'll
questions
get
on that?
I don't see.
Okay. Okay. So what this is all about, guys, is we have to make sure one variable is by itself. Here, we couldn't have done this as is, but we had y by itself here. So we said, oh, that's the same thing. Plug it in and solve. Make a new equation with only x's. Okay. Now we'll see one where we actually go a different direction with it slightly.
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 We're not gonna do example 4.
We're gonna do example 4. So here, x is equal to 2y minus 4. Here, x plus 8y is equal to 16. In either either of these equations is y by itself? No, that's the first time we've had that today. Because in 1, 2, and 3, everywhere at least one of the equations had y by itself. But is there a variable by itself in the first equation?
Yes.
What is?
X.
X. What's x equal to?
What?
Slide.
X equal to
2y minus
2y minus 4. X equal to 2y minus 4. Does it matter? Did I say it mattered that we had to substitute in y every time? No. I said we had to pick a variable. So can we substitute this 2y minus 4 in for something in this equation?
Yeah.
We can put it in for x now. Why am I putting it in for x instead of y?
Because we're doing it backwards.
Because x is the one by itself. X is the one by itself, so I'm going to put this one in for x. Because we're saying this is what x is equal to.
16.
We're not saying that's what y is equal to. This is what x is equal to. So you take this and we put it in place of x in this equation. Yes.
But X isn't by itself in the bottom equation.
Not in the bottom equation. But here, y was by itself, but is y by itself in this equation?
Big no.
Big no, and that didn't stop us either. So we said, hey, as long as one of the equations has a variable by itself, we can do this method. So, can somebody tell me what to write for my equation? Can somebody tell me what to write? 2y minus 4 plus 8y equals 16. I couldn't agree with you more, okay? This 2y minus 4 is the x. That 2y minus 4 is the x. And then we have this plus 8y equals 16. So everything else in the second equation stays the same. What we change is we say, hey, instead of x, we're going to write in 2y minus 4 because it's equal to x. Just like when we substituted in the 3 in the previous problem in this pink here, this kind of magenta, we substituted in for x. So everything else stayed the same except for x became 3. Well, everything else stayed the same except for x becomes 2y minus 4. And then we look to solve this one the same way we've been solving them. You know?
I got it.
Okay, what would I do?
Well, I started by adding the 8 to the 2.
Okay, yep, so we combine like terms, 2y and a positive 8y become what?
That becomes
10y. So you have 10y minus 4 equals 16. Now some people might get confused and say, oh, we have to distribute this 8y. That's not true because there's a plus sign between them, okay? Anytime there's a plus or minus, you don't distribute that, okay? That's telling us you're starting something new, okay? So 10y minus 4 equals 16. What would I do from there, Nectaria?
You add 4 to both sides.
Bada bing, bada boom.
And then 4 minus -4 is just 10y.
Mhm.
That's 20
Big bet.
and then y.
Big bet. Very well said, Nectaria, okay? We add 4 to both sides, just get 10y on the left, get 20 on the right, divide by 10 on both sides, get y by itself. Y is equal to 2. Are we completely done with the problem 100% yet?
X no.
X no. Serenity's saying no. Okay. Presley, what do we have to do? Plug it in. Does it matter which of these two equations you plug it into? No, we can pick whichever. Serenity, or excuse me, not Serenity. Presley, do you have a preference between the two? The first one, why? Smaller numbers. I think it's a great option. Okay? It really doesn't matter which one we plug it into, guys, but we can make our life easier. And I'm a huge fan of that. Let's plug it into some one. X is equal to 2 times what number? 2 minus 4. Also, x is already by itself.
X is
It's kind of like that. These are going to do less math.
Oh, look, there's 4 minus 4 equals 0.
Ooh, 4, 2 times 2 is 4. And Dylan, what did you say 4 minus 4 is?
0.
0.
So then it's 2 comma 0.
We'll try again.
What?
0, comma 2.
Oh yeah, I forgot we're backwards now.
X, comma y. Boy, you always write ordered pairs. The x first to go
I know
alphabetically.
that. Okay, I just didn't pay attention.
This is practice. Practice.
It's
We're talking about a game. It's practice.
It's not our code.
Okay. Any questions to that, guys? Okay. A little bit too.
I would take a nap in grades,
I-
but
I
It's
have
9
a-
o'clock now, 10:30, 10.
I would
So
take a
like
nap in
later
grades,
in your
but you
I don't know why I'm so tired.
I low
That's
key
impossible.
have a plan today to take a nap when I get home and then to go to bed early tonight too.
That's what I do.
I'm like, I want to double this.
I high key fell asleep in grades the other day when we were watching a video, but Eli woke me up.
Okay.
I took a nap
So,
yesterday. It was really
Here's something, And Shades was actually already onto this earlier. He did it earlier when he didn't actually have to. That's a good skill to have because if we flip the page here, sometimes we have to solve for one of our variables before we can substitute. If we look at this first example, x plus 4y equals 6, x plus y equals 3. Do we have any variables by themselves?
No.
No, so we don't know what x is, we don't know what y is yet, we don't know what x is, we don't know what y is yet. So what we have to do, guys, we have to choose one of these variables to solve for. We have 4 options. We can try and get the x in the first equation by itself. We can try and get the y in the first equation by itself. That's 2 options. Or we can do the x or the y in the second equation. So that gives us 4 options of what to choose. So once again, we can choose any of those 4 variables to try and get by themselves. We can choose the x or the y in the first or second equation. That's 4 options. Now, here's the thing. We can ask ourselves a question. What's going to be easiest to get by itself? Okay? And so we have to ask ourselves that question. Now, I would say one of these 4 is harder than the others. Which one of these 4 do you think would be harder than the others? The y, with the 4y in the first. Because here's what would happen. Let me show you how we could get this one by itself. You have x plus 4y equals 6. We'd have to subtract x, right? Get y by itself.
Sure, why not?
And then we're going to have to divide by 4. And yeah, now we get fractions. Do we want to deal with fractions? Not really if we can help it, so don't write this part down. Okay? So we don't want fractions there. Let's see what we like if we end up doing the x in this equation by itself. How do we get x by itself? Subtract 4y. Is x already by itself?
Yeah.
Was that easier? That was less math. We didn't have to divide. Why did we not have to divide here for this x if we had to divide for this y? Because there's a coefficient of 4. So anytime we can, we want to pick something with a coefficient of 1. And these 2 down here would be the same thing. Let's look at this. Let's just see which option we even want to pick. So if we try for this x here, let me highlight which ones we tried for. This was trying for this x. The green was trying for this y. My dark blue is going to be trying for this x. X plus y equals 3. Once again, you don't write this part down. I just want you to look. How would I get this x by itself? Subtract y. X equals negative y plus 3. Is x by itself? That wasn't that bad. Okay. Let's try, last option, let's try getting this y by itself. X plus y equals 3. How do I get this y by itself? Subtract x. Y equals negative x plus 3. Is y already by itself?
Yep.
Yeah. So, as far as options go, were the light blue, the dark blue, and the orange all pretty similar in difficulty? Yeah, I'd say so. All of them, we just had to subtract one thing, and we were done. But the green one's a little bit harder. And once again, the reason why, big picture, I want you guys to think about this to make our lives easier. It's like we like to go with smaller numbers. Once we talk about bank accounts, you know, that paper. Is this y was harder because we have to divide. Since it has a different coefficient than 1, we have to divide, so that's an extra step. And that gives us fractions. Here, all of them were already by themselves. We like that. Okay, so does it really matter whether we pick the light blue, the dark blue, or the orange?
Nope.
Okay. Ray, do you have a preference between those 3? The light blue, the dark blue, or the orange? Any of those with the coefficient of 1?
What?
Orange.
I'm
Yeah.
Remember this one? Between these 3, do you have a preference of which one we solve for?
Yeah.
You do?
The orange.
Cool. We'll do the orange one. It doesn't matter to me.
That looked yellow.
Okay.
I was wondering why you said orange.
Yeah, I was like, or the orange, and you're like, yellow? And I'm like, but,
I meant.
You're good, buddy.
That looks like-
okay. So then, what we have to do, guys, is we say, okay, Ray wanted to solve for this y. We could have picked any of those 3 pretty easily. We could have picked this y as well, but it would have been harder. And we get y by itself, so we subtract x, y equals negative x plus 3. I want you to write this part down. So now, even though we didn't start out in a good place for substitution, are we now in a good place for substitution? Yeah, because we have a variable by itself. We can take this negative x plus 3, and what can we do with it? Plug it in where?
Plugged in x plus 4y.
We can plug it into that y up here. We can plug it into y for the other equation. So we have x plus 4, and what's 4 doing with y? Multiplying, so we're going to have to distribute negative x plus 3 is equal to 6. Okay? So because 4 is originally multiplying, we have to set this up and write it as multiplication there as well in our new equation. Questions on how we got this blue equation, guys? Once again, I have faith in our ability to solve it once we have it here, but I want to make sure you guys know how to get here. That's the new stuff today. Okay. So we distribute the 4. What's 4 times negative x?
Negative 4x,
Very good. And what's 4 times 3?
7, or no, 12.
So we have x plus negative 4x plus 12 equals 6. Okay. Now what would you do here, Chase?
Oh, you'd add the, it would be 3x, which you would add the x to the negative 4x.
Yep.
Negative 3x equals 12, plus 12 equals 6.
Yeah, we'd end up having x plus negative 4x combined like terms gives us negative 3x plus 12 equals 6. So now what would we do? Levi, what would you do?
I would subtract 12.
I think it's a good math move. Negative 3x is equal to what?
6.
Negative 6. Okay, very good, very good. Dylan, what now?
Now, see, the y is 3x.
And divided by negative 3 on both sides. And x is equal to what?
Positive 2.
Positive 2. So we found our x. What do we still need to find?
The y.
The y. Now here's the thing, guys. We said we want to plug it in into where? Either of the original 2 equations. Now, is the y equals negative x plus 3, is that one of the original equations?
No.
Not quite, because we did something to it. Now, is it possible that we made a mistake here? We didn't, but is it possible that we did? Yeah, it's perfectly possible that we did. So we don't want to plug it into something that we didn't work on if we can help it. We want to plug it into something we were given. Because we know these don't have mistakes in them. And we're hoping this doesn't have mistakes. It doesn't, but we're hoping it doesn't. So we want to plug this x equals 2 into one of the original 2. Now of these original 2, does anyone have a preference on which one we plug x into? Okay, why do you say the top one? Even numbers, okay. Anyone have a different preference? Either. I'm fine with either. Okay, we'll do the top one. So we take x plus 4y equals 6, and we go 2 plus 4y equals 6. Okay, and this is to solve for y. We could have plugged it into either equation and it would have been fine. You said, hey, I wanted the first one. Cool, we'll do the first one. You like the even numbers. Subtract by 2, subtract by 2. 4y is equal to what number?
4y is equal to 6.
4. Because 6 minus 2 is 4. Divide both sides by 4, and what's y equal?
1.
1. And so how do we write our answer?
2, 1.
2, 1, x, 1. Ordered pair.
Yay.
Okay. Woo! Questions on that one? Okay. So big picture, guys. Big picture, guys. Everything else was the same, but what did we have to do to start this one? We had to change one of the equations to get a variable by itself, and we talked about which ones to pick. Okay. So if we transfer to example 2 now, we can move on to example 2. Does anyone have of these 4 options of the x, the y, the x, and the y? Does anyone have one of those 4 which we don't want to choose?
The 2.
Probably the 2y. Okay. Now, is there another option that might not be as nice?
Negative 1.
The negative y, because we still have to deal with the negative symbol. So which of the 2 options? So which are the 2 options that are the best choices?
2x.
The x or the x. Okay. Probably want to pick either of the x's. Once again, you can pick this y. You can pick this y, but we can help it. We don't want to do the extra steps to get rid of the 2, get rid of the negative. Okay? Well, let's say, I'm going to say for argument's sake, let's do this one, x. Because that way, how are we going to get rid of this x? What math are we going to do? Add. Would we rather add or subtract?
Add.
Usually we like that. We tend to make less mistakes when we're adding versus subtracting. So if I had to choose subtracting 2y or adding y, I'm probably going to choose to add y. And x equal to y plus 5. Okay. So now what can I do with this information? I can use it how? Plug it in for x in the top equation. I can't plug it in back into the bottom equation because that's the one I've already been working with. I have to plug it back into the other equation. Raise your hand if you can tell me what to write here. Okay, go ahead, Ray. Very good. Y plus 2y equals negative 1. Everything stays the same in the top equation except for x is now y plus 5. As we said, it's the same thing. Okay. So now we have to talk about how do we solve this one. Dalton, what would you do?
Add the y's.
Add the y's. What's y plus 2y? 3y. 3y plus 5 equals a negative 1. Okay. Matthew, what would you do at this point? Yeah. And what do we get 3y to equal to? Negative 6. Victoria, if you have 3y is equal to negative 6, what would you do? Divide normal 3 on both sides. And last probably did negative 3. And y is equal to negative 2 now. Okay. Are we done after we find y equal to 2? So we have to find the x. Okay. Does it matter where we plug y into? No. Does anyone have a preference? Okay, why do you say the bottom one, Levi?
Because when we do it, I feel like if we put the machine on top of it,
Okay, why do you say top?
because 2y, when you plug it in, y being 2 times y, and you get 4, so then we find the x.
Okay. There's just something you like more about that?
Yeah.
Okay. Does anyone have any disagreements? Does it really matter which one we pick?
No.
Okay. You can pick this one, have a negative times a negative becomes a positive. You might say, I don't like dealing with negatives. I don't want to choose this one. Okay, either way. So Levi said top. He is vocal about it. We'll choose that one. X plus 2 times negative 2 equals negative 1. Chase was 2 times negative 2.
It's negative 4.
Yeah, so x minus 4 equals negative 1. Now what?
Add 4 to
Yeah, add 4 to the both sides. And what's negative 1 plus 4? Positive 3. So how do we write our answer?
X equals positive 3.
Yep. And then how do we write our final answer?
Oh yeah, 3.
Very good. 3 comma negative 2. Good job, Presley, right? 3 comma negative 2. Okay? Questions on that one? Okay? I'm going to have you guys do example 3 on your own. I'm going to have you guys do example 3 on your own. Okay? Now, I think there's one choice that's going to be way easier than the other 3 here to get by itself, right? On example 3. I think one of these 4 options is going to be way easier than the others, okay? Which one do you guys think I'm talking about? The x in the second equation. Why, Matthew? It's by itself. The coefficient is 1. Here we have a coefficient of 4, negative 5, negative 4. I see this as far and away our best option, our easiest, simplest, most forward option, less work. Okay? We can pick the others, but I see that as our best option. Okay? So I want you guys to try example 3 on your own. The numbers might get a little big at first, but they end up calming down at the end. Okay?
said, which one is probably going to be your best option? The second X. And here's the reason why. Because here, which one of these doesn't have a correlation? Number one, that X. So that's going to be the one most ready to get by itself. Because even if we move any of the other ones, if we were to move this X across, we'd still have to divide. If we move this 4y across, we still have to divide this. So any other ones, we have to do 2 steps. Here, it's just 1. Does that make any sense? Okay, so how do we get this X by itself? As X. Do we want to move the X, or do we want to move something away from the X? So now, X is by itself. So what can we do with that information? X equals 11 plus 4y. What did we do here when we got X equals y equals 5? Yeah, we put it into one of these equations, right? So we put it into the one before it used it. Here, because we were using the bottom one, which one are we going to put it in? Where are we going to put it in? Raise up what? We're going to put X in place of what? Exactly. So we rewrite this equation. Everything's the same except for X. Now this. But the 5, you don't have to, because everything stays the same except for this 1X. So now, what's 5 doing with X? So that means 5 is multiplying all of this guy. Yep. And now we solve this equation. That makes sense?
Thank you.
Second. It's over there.
So, we're starting at 4y minus 20 minus 1 is 16. So yeah, 55 16. Divided by negative, okay, what is this? We have to adjust that and then negative 4 here. I think we're going to get a much nicer part for your team.
Yes, we do.
I agree with this. And then we plug it in. Is X equal to that or Y equals to that? And you have X, right? So what did you do? Yeah. What did we get?
So we did this.
You did the
So we did it, it's wrong.
So we just need to change which one we're plugging in. Very good. Also, did you do your
Positive, positive, okay.
So this is what X is equal to, right? We're going to put it in for X or for Y. So 4 minus 5, maybe put everything of this over X. They're saying it's all X. So if you said negative X, this was negative X plus 3 was all Y here. So we put it all of this in. We're going to put all of this before y plus 11 into that X. Doesn't always check. It's right there.
You're what, boy?
Hey, buddy.
No.
What? Did I do it like so far? Or did I do it wrong?
No.
That's wrong. Right, add one.
Good job, man.
Hey, yo.
Okay.
negative 5 times 4y will kind of 20y is that?
Oh.
Instead of 24y, what's that become? 4y plus negative 16. You're solving for that.
Negative
Yeah. Let's try that instead. Okay. That's gonna help us out a little bit. Okay. Yeah, no problem.
Bruh. Yeah, 5 times 11, that's 5.
Wait, so I have no eyebrows.
Bruh.
So we write this equation as being the same except for now y is 4.
Oh, bruh. I need that for this week. Oh, jeez. Been there for Like what? Where?
Oh, somewhere, that's actually right in the
I write big boy style.
minus 4. You don't have to do
Is
it.
equal to 16. No one.
Okay.
I'm just
You
gonna.
know why it's wrong?
Ah.
What kind of view is that?
No one. I don't care.
You gotta turn on the water.
Don't care.
And turn towards that, you want to turn towards that.
Don't care.
Hey, everyone, let's have our attention up here. Okay, we're gonna talk about this as a class. Okay. So we talked about why this x would be the best one to solve for, our best choice, our simplest choice. Okay. That's gonna give us the least amount of work and struggle. Okay. Because this x is a coefficient of 1. We solve for that. We get x equal to 4y plus 11. I saw some people write 11 plus 4y. That's okay. Whether the 4y or the 11 comes first does not matter for this. We plug it into this x, and we get the equation 4y minus 5 times 4y plus 11 is equal to 9. Now from there I saw us doing this, which is great, distributing 4y is equal to negative 20, 4y minus 20y minus 55 is equal to 9. Right? Then we take 4y minus 20y and we get negative 16y minus 55 is equal to 9. Add that 55. Then we got negative 16y is equal to 64. Then we have to divide by negative 16. And we got y is equal to what number, guys?
Y is equal to
Very good. Y is equal to negative 4. But we weren't quite done yet. Because now, what you have to do is you say, okay, let's plug it back into either of these two equations for the y. Now, as I was going around and asking some people, hey, which one do you think is easier? I got the same answer both times of saying, I think the bottom one would be easier, and I agree, because there's just less numbers going on there, okay? So even though 11 is bigger than 9, well, 1's less than 4, 4 is less than 5, I choose the bottom. You could choose either. X minus 4 times negative 4 equals 11. Put the negative 4 in place of y, everything else stays the same. So x plus 16, because negative 4 times negative 4 is 16, equals 11. Subtract 16, subtract 16, x is equal to negative 5, and we write the answer as an ordered pair, negative 5 comma negative 4. Okay? Questions on that one? Okay. Overall, we seem to do pretty well, okay? It is awesome to see some people helping each other as well. That was great, okay? We're going to skip example 4. We're going to go on. We're going to speed around a couple special cases, okay? Because we still can come across parallel or coinciding lines, and that's our no solution or IMS infinitely many solutions, okay?
Amos.
We can still come across those, okay? So what happens here is, hey, wait, is a variable by itself in this first equation? No, but is it in the second equation?
Yeah.
That's nice, we don't have to solve.
Ain't good.
So we put this 2y plus 3, we put it in place of x. So now we have 2 times 2y plus 3 minus 4y equals 1. So we saved ourselves those first few steps here. Instead of having to solve for a variable, we already have a variable by itself. So we can say, oh, all of this goes in place of x. So we rewrite the first equation. Everything stays the same, except for x is now this 2y plus 3 that's in the parentheses there. We go through, we solve like normal. We distribute. 2 times 2y is 4y. 2 times 3 is 6. That minus 4y is still there, and it's still equal to 1. Now what do you notice as we combine? What's 4y minus 4y? 0. So do we have to write that 0y?
No,
we
there is
can
no
put
y
6 equals 1. But wait, does 6 equal 1?
No.
And what happened when we got to a non-true equation, a false equation?
It's a no solution.
That was no solution. So that means that those two lines are actually going to be parallel. Okay? So just like when we graphed parallel lines for the homework that was due today,
Dang.
and we had no solution, this is the same thing. Okay? Whenever we get through and we solve through and we get to a false equation again, we're back at no solution. Okay? So if anyone was a betting man or woman, what do we think this one's going to end up being?
That's gonna be
Probably IMS. Okay? Let's try it out.
Yeah.
Nothing by itself here. Here's a y by itself. So I'm going to take this 2x plus 5 and plug it in for which variable? Y. Everything stays the same, except for y now becomes 2x plus 5. Everything stays the same, except for y now becomes 2x plus 5. We go through, we distribute. 4x, negative 2 times 2x is negative 4x. Negative 2 times 5 is negative 10. That's equal to negative 10. Okay, we look what happens again. What's 4x minus 4x?
It's 0.
0. So negative 10 equals negative 10. Is that true?
Yes.
Yeah, when we get down to a true equation like this, the same thing on both sides, that is our IMS. Okay, I know I sped around those couple, but I feel a lot better about how we're able to do on these substitution ones, especially after we got through that example 3. I feel like a lot of us got a lot better on that example. I think this is kind of fun. This is actually one of my favorite things to do in algebra. In all of math, this was one of my favorite things to do.
Wait, you like this? Are
Well,
you
that's actually
on
gonna
something? He's
Yeah,
on
it's gonna come in a
live.
couple chapters.
Won't we use that algebra too?
Okay,
Say he's
I'll
high
do-
on live.
we'll use it now, but we'll do
No,
it here
try
too.
your high.
Okay? Hey, so guys, here we have, I have some specific instructions on what we're doing, okay? I don't want you guys to do all 20 problems, is that okay?
Yeah,
Okay,
you can make
I'm
us
gonna trim it down, okay? I want you guys to do every other odd,
Every other odd.
as well as numbers 2 and 18. So every other odd, that means if you start at number 1, are you doing number 3?
You're doing number 7.
No,
You're
no,
number
no.
five.
You're doing number 5.
And two.
Oh.
And two
If you
and
do number
two.
5, are you doing number 7?
No.
No, we're doing number
9.
9. If you're doing number 9, are you doing 11? No, you're doing 13.
Wait, what?
So 1.
So you're doing like 1.
1,
Five.
5, 9. Oh, never mind. Sorry.
Every other odd, you're you're skipping every other odd.
I wasn't
Okay.
reading it, but I.
And then I also want you to do 2 and 18. So you have to do 1, 2, 5, 9, 13, 17, and 18.
Why don't you have a dad joke about 18?
I don't know. Okay? Questions on that? Okay, I know this is a long one, guys, because we had some technical difficulties at the front of it, but I think you guys ended up doing really well, and hopefully these 7 problems aren't too bad